factor trees, you'll often get the question, write a particular number, in this case 24, as a product of its prime factors in index form. To do that, we've got to identify what prime numbers multiply together to give us 24, and to do that we make a factor tree, where we just split 24 into pairs of its factors over and over again until they're all prime. There's 3 pairs of numbers that we could use. Never use a 1, it doesn't help us. 2 times 12, or 3 times 8, or 4 times 6. Any of those pairs is fine. I'm going to use 4 times 6. Neither of those are prime yet, so this one, 4, can be written as 2 times 2. 6 can be written as 2 times 3. Once every number is prime, that means that 24 equals 2 times 2 times 2 times 3, and to write that in index form, that's 2 cubed times 3. An optional extension usage of a factor tree: use a factor tree to show that the square root of 36 is 6. Well, they said use a factor tree. Now, yes, we can split it into 6 times 6, but that's not enough yet. It's 2 times 3 times 2 times 3. So 36 equals 2 squared times 3 squared. Now, anytime you've got a set of prime factors where you can split it into 2 identical groups, 2 times 3 times 2 times 3, you know that one of those is the square root, because the square root says, what did I multiply together, what identical number, to get this? 2 times 3 was multiplied by 2 times 3 to get 36. Therefore, the square root of 36 is 2 times 3, which is 6. It's a pretty easy little example. You can extend that to cube roots, which is really useful. If you can get 3 copies of the same thing multiplied together out of your index powers, you can find a cube root of a number very easily.